Okay, question 5. Look at the circuit below. Ammeter A5 reads 3 amps. All the resistors have the same value of 10 ohms. Find the readings on ammeters A1 to A8. So most of the annotation we can do here on the diagram itself. So we're going to use, for these two resistors here, I'm just going to put a green dot on them, V equals IR, which for these is 3 amps multiplied by the resistance, which is 10, which gives us 30 volts. So I'm going to label 30 volts on this resistor and 30 volts on this resistor. Now at this point we've established that across this part of the circuit there is a potential difference of 60 volts. So if I connected a voltmeter all the way across here, it would read a value of 60 volts. This of course also means we know the values of the voltage at all other parts in the circuit. So this branch only has one resistor and it's got a potential difference of 60 across it. This branch has 3, so they're going to switch 20 volts, 20 volts, 20 volts. And the cell itself also must have an EMF of 60 volts in order for the circuit to work. So I've started using green and then usually green everywhere. So let's do different colors for each branch. Red for this one. We'll do use black for the one at the top. Okay, so then let's deal with the purple branch next. In the purple branch, we can say the current is the voltage over the resistance. So for one of these resistors, that's 20 over 10, which gives us a value of 2 amps. So that includes A3 and A4, which are both 2 amps. Then over here at the side, we've got A6. We can easily see that whatever the value of A4 and A5 are, have to combine together to give A6. So A6 must be equal to 5 amps. Then in our red branch in the middle, we're again going to use the idea that I is V over R. So here, this is the 60 volts we've just worked out over 10, which is 6 amps. So A2 has a value of 6 amps. Then for A7, A8 and A1, they're all going to be the same, and we're combining these. So we've got the 5 amps coming in through this branch, added to the 6 amps we've just got over here, gives us 11 amps for the other ones. So A1, A8, and A7. Is 11 amps. 11 amps is a silly high current. You don't get currents that big in real life, but in the context of this question, that's the answer. And then the last part says find the EMF of the battery. Well, we've kind of done that already, haven't we? Because we've written it down up here. The rule we're using here is that around any single loop of the circuit, for example, this one, the sum of the PDs has to equal the sum of the EMFs. So we've already established that the EMF of the battery is 60 volts, and we got there through Kirchhoff's second law.